In the previous lesson we talked about UDD assumption. So in UDD the function tpx mu x plus t was constant and this was equals to qx. So using this assumption we derived the formula for tqx equals to t times qx, right? Okay, so now in this video our focus is on CFM assumption, constant force of mortality. So now if you can recall from the previous video, the definition of tpx in terms of exponential is exponential minus integration 0 to t mu x plus s ds. Now here in CFM we assume that the mu x plus t is same as say mu x when t lies in between 0 to 1. So mu x is basically constant in between integer ages. Okay, so that's the assumption in CFM. The force of mortality is constant in between integer ages. All right, so now we can integrate this exponential. Okay, let me write e to the power minus, so this mu x plus s will come out of the integration, so this is mu x times t, right? The integration of ds is simply t, where t lies in between 0 to 1. Now can I write 1 px equals to e to the power minus mu x? Okay, so instead of e to the power mu x I can substitute 1 px and then to the power t. So this is our formula from CFM, where t lies in between 0 to 1 and x is the integer is same as UDD. Okay, so now let's do a very simple example. Suppose you are given 0.25 Q40, then first our task is to convert this in terms of P, 1 minus 0.25 P40, and then we can write this as 1 P40 to the power 0.25. okay, now let's do another example. Suppose you are given 2.25 Q40. Let's change this in terms of P, 2.25 P40. Now here t is not in between 0 to 1, so our task is to break down this using the principle of consistency. 1 minus 2p40, 0.25 p42, right? So this is 1 minus 2p40 times 1p42 to the power 0.25, and then we can write this in terms of L, 1 minus L42 divided by L40 times L43 divided by L42 to the power 0.25. And from the table we can look at these values and then we can calculate this. All right, now let's do a little bit complex example. So this is 0.25 p42.1. now how can we calculate this, because the x is not the integer is? So what can we do now? Can we write this as 0.35 p42 is equals to 0.1 p42 times 0.25 p42.1? If you sum this up, this is nothing but, like here this is 42 plus 0.35, right, which is 42.35, and on the right side if you sum this up, this is 42 plus 0.1, which is 42.1, okay, and then plus 0.25, which is 42.5, 0.35, right? So we can definitely write this using the principle of consistency. Now from this we can say that 0.25 p42 is 0.35 p42 divided by 0.1 p42, or I can write this as 1 p42 to the power 0.35 divided by 1 p42 to the power 0.35, or I can write this as, sorry, this is 0.1, or I can write this as 1 p42 to the power 0.25, right? 0.35 minus 0.1 is 0.25. So here you can observe that instead of x, I have written the integer part of x, and this t is raised to the power 1p42. Okay, so from this example you can develop a trick that whenever the sum of t and x does not cross the integer is, we can write this as 1p42 to the power 0.25. We can write the integer part of x in the subscript, and then in the power we can basically write the t. Okay, so we can take another example. Suppose this is 0.25 p42 40 point, let's say 0.1. so we can write this as 1 p40 to the power 0.25 using this trick. Okay, now let's do one more example. Suppose you are given 2.25, okay, let's say this is 2.75 q40.5. to change this in terms of p, 1 minus 2.75 p40.5, and then we can break this down using the principle of consistency, because the t is not in between 0 to 1. So we can write this as 0.5 p 40.5 times 2 p41 times 0.25 p43, right? And then we can write 1 minus, since the sum of x and t does not cross the integer is, we can write this as 1 p40 to the power 0.5 times 2 p41 times 1 p43 to the power 0.25. okay, and then we can solve this looking at the values from the table. So this is all about CFM. All right, now let's do one proof using the UDD assumption. So the proof is a bar x dash n, and we have to prove this I over delta ax dash n, okay, using the UDD assumption. All right, so now here can we write this term on the left side as a bar x dash 1 plus vpx a bar x plus 1 dash 1 plus v squared 2px a bar x plus 2 dash 1 plus so on, and the last term will be v to the power n minus 1 px a bar x plus n minus 1 dash 1. So can we write this? This goes with the logic that we have separated the term assurance for 1 year, and then again the person must have survived for that year, and then he has the term assurance for the next year, right? And then again we have multiplied the probability of survival for the 2 years, discounted back for 2 years, and then again the term assurance for the next year. All right, and this goes on. Now can I write a bar x plus t dash 1 is nothing but integration 0 to 1, because this is immediate, so integration 0 to 1, duration is 1 year, vs sp x plus t mu x plus t plus s. We already have x plus t. The term assurance has begun from x plus t. That's why I have assumed a dummy variable inside the integration, that is s, and this is ds. Okay, so now from udd we assume spx mu x plus s equals to qx, right? So can I write qx plus t is spx plus t mu x plus t plus s. Then from the integration, from this part, I can say that mu x plus t will come out from the integration, because we are integrating with respect to s, and this integration 0 to 1 e to the power del, I'm writing vs in terms of e to the power del s ds. Okay, now if we integrate this, we'll get qx plus t times e to the power del s divided by minus del, and the limit is 0 to 1. So you'll get 1 minus e to the power minus del divided by del. Okay, then we can write qx plus t times 1 minus v divided by del. So we have derived x plus t dash 1 is nothing but qx plus t times 1 minus v is d, so this is d over del, or qx plus t, d is nothing but iv, so we can write iv by del. Okay, now we can use this result in this expression. Okay, so we have a bar x dash n equals to a bar x dash 1 plus v px a bar x plus 1 dash 1 plus v squared 2 px a bar x plus 2 dash 1, and so on up to v to the power n minus 1 px a bar x plus n minus 1 dash 1, right? Now we can put this result in the first term. So this is iv by delta. I'm going to take this as common from all of these terms, and then instead of x plus t we have x, that is t equals to 0. So this is qx plus v px q x plus 1, right? And then plus v square 2 px q x plus 2, so on up to v n minus 1 px q x plus n minus 1, right? Now let's multiply this v inside the bracket. We'll get v qx plus v square px qx plus 1 plus v3 2 px qx plus 2, so on up to vn n minus 1 px qx plus n minus 1. Now this expression, we can write this in terms of summation, where k goes from 0 to n minus 1, v to the power k plus 1, k px q x plus k. And you can check this by putting the values. So when you put k equals to 0, you will get v, and then 0 px is simply 1, and then this is qx plus 0, which is qx, right? And at last, if you put k equals to n minus 1, you will get vn. So vn n minus 1 px, n minus 1 px, and then qx plus n minus 1, right? So this is correct. So now I over delta, now this summation is nothing but a x dash n, if you remember from the previous video. Okay, so we have proved a bar x dash n is nothing but I over delta a x dash n using UDD assumption. Okay, so without UDD we cannot prove this. So this is very important to mention, that using UDD assumption we have proved this result. Okay, this is also true in case of whole life assurance, immediate whole life assurance. So this is approximately equal to I over delta ax using UDD. All right, so this is all for this video, and I'll see you in the next video. Thank you so much for watching this video.